Okay, so review question 2, and the topic has moved on to entropy and probability. So the question context is we've got two distinguishable particles A and B. They're contained in a box. The box has 3 imaginary boundaries. Actually, it's only 2 imaginary boundaries, which gives us 3 sort of distinct areas in the box. That's sort of what I meant there. If the particles move around the box randomly, what is the probability of finding both particles in the middle segment of the box? So for a sort of a general note, this probability is going to be equal to the number of microstates, sort of arrangements, for a given macrostate divided by the total number of microstates. I'll explain what this means now in a second. Okay, so we basically want to figure out how many possible different arrangements there are for 2 distinguishable particles in 3 different areas. That would be our denominator. So the total number of microstates were in a sense for how many ways is it possible to arrange 2 particles in 3 different areas. Then divide, and then our numerator will be how many of those correspond to having both particles in the center. I'm hoping to already know that answer. There's only one way to arrange both particles in the middle, so I already know that my numerator is 1. So we've got 3 different possibilities, and we've got 2 particles. So the total number of ways we can arrange these particles uniquely is 9. 3 raised to the power of 2. So the number of possibilities raised to the number of particles. So the correct answer is 1 over 9. But if you're struggling with the math, you could. This one's not counting up 9 states. It's a little time consuming, but it's possible. So that's what I'll try to do here. So I'll start with maybe drawing some of these out. So I'll start with here with A is red and B. So I'll do the sort of cases of where we have the two arranged in each individual section. So I'll do this. So we can put A and B in the left, put A and B in the middle, and then put A and B in the right. So again, this is showing that there's only one way to arrange both of them in the middle. And then we can put both of them in the right. Then I'll start with I'll consider the cases of where I can arrange A in the left. So if I keep A in the left, where can B be? It could be in the middle, or I keep A in the left, B could be in the right. So that's the only 2 arrangements that you can have in which A is in the left. So see all of this. Okay. And I can do something similar. We're going to say that I have B in the left. So I can put A in the middle, or I could And now I can think of doing similar things of here in a sense I only have one case of where I have A on the right, and then I can think about putting B in the middle. So A on the right, B in the middle, and my last possible one is to put B in the right, but put A in the middle. And there are the 9 unique ways in which you can arrange these two particles amongst 3 separate areas. So, 1, 2, 3, and then I get it 4 and 5, and then I did 6 and 7, and then I did 8 and 9. And the only possible way you can arrange both in the middle is this one. So that leaves us with a probability of 1 over 9, which should give us, of course, choice B.